Alright, this is going to be me making a clone of Swift Stitch, a game by Sophie Holden. I'm going to call it Swift Switch, because that's what you do, you switch up and down. You can Google, I'll put a link to what the actual game is. Basically, it's a game where if you touch the screen, it'll change the direction you're going. I'm going to take the steps and go through how to build it in my game engine ported from Flashpunk, AndroidPunk. So we have the project here. We have to add in AndroidPunk. In order to do that, you have to have it in your package explorer. That's not how you do it. You go to Android, and then you add your library project. Apply it. Okay. This assumes that you know how to make a basic Android application, which you do by just going New Android Application. Fill out your various information. So now that we have the Android dependency, it has the JavaScript library, and all that good stuff. Now we create a activity, which is basically a window or something in Android speak. So activity, and we're going to base this off the AndroidPunk activity. What is it called? I have to go figure that out. It's named AndroidPunk activity, not AndroidPunk activity. Simple mistake. Punk activity. What's nice about this game is it really doesn't use graphics. It's all vectory line art, so I don't need to have any art packages loaded in, so it should be pretty quick to work on. So now that you have your punk activity, you will want to define a few things statically. Some things of interest are the width and height, which I think you set by saying static. Nope. fp.screen.stat. It's one of those things where I guess I'll just look it up. Punk activity, static, width and height. We'll just make ours landscape as well. Just copy paste a lot of this. This is basically the same thing I do for all my games I make with it. I might as well clear out all these as well. Alright, so now that we have our static, we define width and height. It'll scale that based on what the actual thing is. Now I mentioned this engine class, but I do not have one, so let's make one. Swift engine. Engine from AndroidPunk. So a Swift engine needs to override a few constructors. So these define or get defined by the punk activity. So it gets past the width, the height. What the frame rate was selected, you can change that in your main activity by assigning a frame rate or setting that it's a fixed frame rate. Otherwise, it'll render as fast as you can, and you can use the elapsed variable to figure out how much time has passed. So yeah, you'll get past this fixed. Mostly these are not very necessary, but you do need to have them for your engine. Now, when your engine gets created, you probably want to start up a world, a basic world. Save these so they stop complaining. So in the other punk activity that I have an override of onCreate, which is not necessary because I do not do anything. That is because we specified this engine class here. by using a reflection, so that it doesn't need to know. You don't have to actually start the engine, it'll auto start the engine. And like that. Alright, so the Swift engine, here we're going to want to create a simple world. Just go and create one. It's going to be the Swift world. And load it from AndroidPunk. And we'll inherit constructors from superclass. So here we go. We have our Swift world. Now let's load that up when the engine starts. I believe. I just like to look at old things just to be sure I'm doing things correctly. Alright. You only need to implement the one constructor. The other one just is a simpler version of it. So we'll just make use of that. So fp dot we'll set the world to a new Swift world. So from there, the engine will get spawned when the program starts up, and then we will set the world to our new Swift world. Now our Swift world currently does nothing, so let's change that. While we wait, I'm going to open up a virtual device so we can see it on the screen here. Let's go with ICS. Launch. We rotate that, bring it there. We'll come back to that later once it finishes starting up. There we go. Alright, so in here, let's just create some stuff so we can see it work. Let's actually quickly create a entity or a little character, which is just a triangle. Player, and it's an entity. And the entity comes from AndroidPunk, not from the Android project. Let's inherit constructors. So you only really need the XY one, so I'm going to use that. So we can specify where our player should spawn. Fix up all my parentheses, and we'll just create a triangle to be this thing's graphic. So we can make use of the shape library in AndroidPunk. Shape graphic equals shape dot. So shape is a factory, so you can tell it to build you a triangle. Let's just do something very simple. We're going to center ourselves on it, and we're going to be, I don't know, 5 pixels by 5 pixels. So point 1 I'll do at the very top, so let's do -5. So the screen grows down in the Y variable, so this is going to be -5, and this way our triangle will be pointing up. We'll probably change these sizes because I'm just eyeballing it. So 5 for the top point. Now we're going for the right point. So that's 5 out and 0 on the X, and then -5F. And so this triangle's a little squished, but whatever. So we set our graphic, and whenever we spawn a player, it should draw like that. Let's set the color to just be white for now. Uses hex colors to set it, so it's pretty simple. We won't have it do anything quite yet. We'll go back to our world now. I always prefix my privates and things like that nature with an M. I don't know, it's just a standard of Android type stuff. So when we create our world, and there's a begin function that you can override. That's when this scene is added to the actual engine. It gets run. So in this we will create our M player, and we'll position it in the center of the screen. Let's go half height, or half width, and half height. So now if we run this, it should add this to the screen and then start rendering it. I have to import. You can quickly import by floats. So I have to cast these down. The one problem with a statically typed language. Alright, there we go. So let's try and run these. Just unplugging all my phones. So it'll run the actual project on the emulator, which we have launched. And let's see what we got here. The emulator is kind of slow, but is it going to launch it or not? Let's try run that again. Oh, this is an issue that I didn't manage. When you create an Android project, you have to specify the activity to run it as, otherwise it doesn't do anything. You can just copy one from the sample directory of the actual Flashpunk thing. Should cover you. It adds your launcher and all that stuff. There's no reason you can't copy it all as long as you rename it. So let's go back, replace their application with our application, and then we have to change this to be our main activity. There's no reason that I couldn't change the Punk activity to read some resource to figure out what class to run, but it's just easier if you do it yourself. And so it uses the theme of AndroidPunk and sets it landscape. If you wanted your game to be portrait mode, you can change it here. That way the width on the thing will actually be the width of your phone in a portrait screen. So that's where you would go to change that. Note the hardware accelerated true. It's not actually necessary because Flashpunk uses OpenGL instead of the canvas. So now that that's done, if we launch our application again, it should actually install and run it this time. Alright, there it's starting it. I found the intent. And let's see what we got. A whole lot of nothing. So it fell back to a software renderer, which kind of sucks. Alright. So there should have been something here, but there isn't. Now why might that be? For one, in our Swift row, we set it at half and half. So it should be right in the center of the screen. So the issue here is we did not add the player to the scene. This adds it to a list to be added in the next frame, and so that way you prevent actually updating things that you meant to remove and hitting like null pointers, exceptions, and things like that. So let's relaunch that. Just see what comes up. So there's our tiny triangle. So let's just make that a little bigger. Go to the player, make it taller. It's going to be, so I think that's equilateral. So let's just make it 20 pixels wide by 15. So run that again. while it's loading, I'll just show off that you can change the angle of something. Now, is this angle in degrees? So keep that in mind, and it is rotation clockwise. So there's our triangle. It's looking a bit bigger now. Why don't we just run it again with the rotation? And while it reloads, there, so it's been rotated 90 degrees. Let's add some information to our player. So in this game, the thing automatically moves left to right, or whichever direction it's going, and if you tap it, it moves perpendicular to it in a specified direction. So it needs to know which directions it's going and how fast it should be going. How fast it's going is going to be a constant. Let's say we move 100 pixels per second. Now we need the direction vector. I'm just going to use a point here. And we'll make it automatically go to the right off the start. Import the point. Nice shortcut is Control-Shift-O, which will auto-import anything that is necessary. So it'll handle all this for you. So we have our direction. Now what we need is a way to actually move the object. Do this with an update. So in here, let's see. We can do no, silly. All right. If mDirection.x greater than 0, it means you're moving right. So then you take your x position and you add. It's actually unnecessary, as I realize now. You take mDirection.x and you times it by speed. We'll set it to -1 when you're going to the left. And then you times this by the special static variable lapsed. So this will move it based on how much time has passed since the last frame, so it keeps speed in pixels per second. So since this is going to be in pixels per second, and we want to keep it precise, and this is going to be very small, it's going to be multiplication, we don't want to lose our information, so we'll change it to a point f, which means a float, so it'll keep track of. That's actually wrong, it's not what I want. We need to keep some private x and y's that are floats. The direction will just be 0 or 1 or -1 in each direction. But if we create these mx and my's, then we don't lose the rounding errors. So now we can set her to the casted mx and y. So now when every time it updates, it'll move 100 pixels per second in the direction of the x and y. So it'll move to the right. While we're here, might as well add the, if you're touching the screen, it goes perpendicular. No, we'll just do this first to show that it's moving to the right. Alright, so run it. It's going to quickly fall off the screen, but we'll get back to it. So here we go. Oh. The values are actually not initialized properly. So mx should equal x and my should equal y. That's why it was at the top. My was not set properly, so it immediately equals 0. that's a problem. Fix that up. So now that it's running, see, there it goes. Pretty slow actually, but that's just the emulator being slow. Alright, next up, let's do if you touch the screen, it changes the direction. So that means you need to know if your next direction should be up or down. Similarly, if your next direction should be left or right. These are going to be booleans for if you're up, down, or if you're up or down. Go up, and that equals, can't remember if this is true or false off the beginning, or it's probably configurable. So let's add that to our constructor. Let's reverse those ordering because I don't like the way that looks. Right, so we have the ability to pass in those, but you don't want to always. Let's just say default is that you're going up and to the right, so or let's go, you're going down at the start. So let's change that to be start down. So we create our booleans for which way we're going. And set those equal to the values that are passed in. So now we know if we're supposed to go right or down. And that basically eliminates the need for this, I guess. Oh well. You're always going horizontal if you're not touching the screen. So, if now this we use the input class to get a mouse down, then you want to be going either up or down based on the m down boolean flag. So if m down, that means you're supposed to be going downwards, then you can get so this is all sort of useless here, but oh well, we'll do it. So x is 0 now because the mouse is down and we're supposed to go down, so you don't add anything to it. Just get rid of that. Now when the mouse is down and you're going down, that actually means positive in the screen orientation. So let's go speed times p.elapsed. Otherwise, you go upwards, which would be minus equal. Alright, so if it's not pressed, we want to be going right if you have M right. I'm kind of moving ahead because in the game you can go through these gates that change the way your directions go, and so you can use these to turn around and things like that. It's a really cool game. If you haven't played it, you should go check it out. I believe it's available on the iPhone. So if you want to go, if we're going right, then you add speed times p.elapsed. Now since I've been doing this a lot, delta, you're always moving by this, so it doesn't matter. Alright. So keep that there. So now if you have the button pressed down and you're going down, then don't do that. If you don't have it down and you're going right, then it'll add to your delta. So let's go try this out. So it means if I push down, my triangle should go down instead of to the right. Look at that. So let's rotate the triangle just so it looks better. It's sort of an instantaneous thing, so we won't even tween to it or anything like that. But if you're down and you're going down, so where I should save the shape graphic so we can change and deal with it. You don't need that anymore. I'll change this to M graphic. And we'll change this in the update function, but it's good there to be default by default. So if mouse down, you're going down, then M graphic angle is going to equal 90. No, not 180. Turn right around. If you're going up, then it's supposed to be 0. If you're going to the right, it's 90. If you're going to the left, it's 270. So let's go make sure that works. And look at that. Looks pretty good to me. So let's exit the game. So what's next? We could use some levels, we could use some zones. Let's try crashing into something. So just to be simple, I'm going to create a block. And it's an entity. So this block entity, I should have grab a constructor for it. We'll give it an X and Y. And let's just add a width and height. And so we can set a hitbox to use width and height. We need a graphic for it. We don't really need to keep it around, but we do need to use that width and height. So use our thing. Let's say X and Y. This is the top right corner of it, like so. Let's make it dark red. So there we go. Set the graphic. So there we have that, and it has a hitbox. Now we have to set a type. So a good way to do this is make it available so other things can check if they collide with you. So you have a block, and set the type to it. So here now we have a block, you give it X, Y, width and height, and it'll generate the thing, make it red, add it, and set the type. So let's add it to our world when we begin. So that's M block. Let's put it in the path of the thing so we can hit it every time. So it's going to be at half height, but it's going to be at the end of the screen, minus a bit. My screen is 800 pixels wide, so let's just call it 750. And it's at FP half height. And we're going to make this block 30 pixels tall. So we want it centered in the middle. It's 30 by 30. So we add our block. So now when we run it, we should have a block in the middle of it. Of course, it doesn't do anything other than just be there and get drawn, but we'll add the collision detection and things like that in a second. Darn. It's not exactly what I wanted. Don't see any problems. Create a block. 750. Set the graphic. It's color red. It's width height. Why wouldn't it draw? I get the feeling my square just doesn't want to draw like this, but I don't see why it wouldn't. Didn't get any errors either. Maybe it just wasn't saved. Oh, one thing about rectangles, they get offset from your position, or your graphic is offset from your position. So it was actually drawing at 750 times 2. So that was off the screen. So let's, restart it here. And there you go. There's our red block. So as I said earlier, the triangle will just pass right behind it, like so, and so nothing happens actually. Let's just do something to check to see if our player hits it. So let's go to our player. So in our update, before we move it to the new location, we can do a collide. So if collides with a block, no, we're not going to be running into things. So if we collide, we're done. So let's just do it after we move our position. So if we do collide something, then it will return a pointer to the entity, which then you can say is if it, and it's null if it's not, or if you don't hit anything. So if it is not null, it means you hit one of the blocks at your new position. And so let's just print out the log, hit the block. And when you hit the block, we'll set our x back to 0. So we'll restart at the start. Add the log. That's one of those Control-Shift-O shortcuts. Now, it's not a very good idea to do that. So the convention is you have a tag variable that you then use for all your logging from an object. Like so. So let's see if we hit the block now. And here we go. Can't dodge it, can't dodge it. Now this isn't going to work so much. Oh. Interesting. So hit the block, teleported, but still went on. Now this is because the mx my was not set to 0. So as soon as the mx was greater than the block and you no longer collided with it, it went back to wherever it was. So you should really be doing this before you set the values. That way we just change mx to what we need it to be. And so we just use mx here, my. Now those have to be cast to int, but. So there we go. If we do get hit, it'll set that to 0. And then you'll go on your merry way. So really you should just restart when you do that, but. Oh, well. Actually, yeah, let's just do that. It'll be easier. So I'll just create a new world and we'll go there. And then we'll launch it. And so here we go. Let's see if we hit this block here. You hit it, you restart. Now, since my player doesn't have a width to it, it only hits when the start index of it hits. So let's add a hitbox for our player. And so our width of our thing, now this is why a square would be the best choice. It's 15 tall by 20 wide. So 15 by 15, just to be safe. Really, this hitbox should rotate every time you rotate. So actually, let's just do that. So if you're going up and down, your width, you are 15 tall. Classic mistake here is that the X index should probably be in the top left corner, so it's how everything else is done in Flashpunk. So now I have to make it or change some things up here, which I'll probably do by changing things up here. Go to 15 by 20 wide. Width by height. Set hitbox. It likes integers, so get rid of those. Now in order to make this start at the top point, we have to draw it from 0. So if we just add 15 to all the numbers in the y direction, and we change this to be, if you're going left and right, you're actually 20 pixels tall by 15 wide. Now in this case, center origin will take the size of the graphic and sets it to half width so that the rotation happens on your point. I don't know if it was doing it before. It's hard to tell. So the origin points was at the bottom of the thing. Oh, I missed the red block, so it's not going to start over again. Alright, so let's try some of this out. So we've made it from the top corner and we've changed our hitbox based on it, so it should hit it sooner this time. So it kind of changes on a dime there, eh? Instead of rotating around the bottom corner point. So it should still hit it. Oh, dang. So it doesn't hit it. That's disappointing. So the top left corner, and it's 20 pixels based on from that. Oh, 15 in front of it, which seems correct. Wait a minute. Oh, it was already centered around origin, except for the y values. Interesting. Alright. So, originally is 20 by 15. Let's just center this because we can. So our first point's at -7.5 and the bottom points are at 7.5. So there, our origin is now in the center. We don't need any of that. But we do for the hitbox. Center origin will also adjust how hitboxes work, which means I need to run it every time I set a hitbox, which is a lot. Let's run that again. I think I'm just going to start pausing in between the loading, so you don't have to wait as long. So here we are, it's running. And rotation looks a little bit better there. Now let's just see if we crash into it. And yeah, see it hit as soon as the tip hit it. If I rotate immediately, I should hit the side. Oh, too slow. Oh well. Let's see if it, since our thing is a square, it'll still hit it even if it's on the kind of corner of it. We can change this up later, but for now we'll just leave it like that, because it means if you rotate you probably hit the wall. Just for simplicity, let's leave it there. Alright, so one way you can make a game out of this is you just place blocks everywhere. So let's add a couple more blocks. I'm just reusing this variable, it's not necessary. We could just put it right here instead of setting a variable for them, because we never use them again. Let's put it at half width. Touch your eye. And then let's put it at half. Let's put it at height minus a little bit. 30. And it's a block of 30 width, so if we go straight down, we'll hit this block. Let's put a few more blocks here now. Let's put one next to it. Plus 15. So that'll be 2 blocks right next to each other. Might as well start them off at minus 45. So this should be 3 blocks at the bottom that you will hit. And we're back. There's our 3 blocks at the bottom perfectly. So you can now make a game of trying to escape a block maze going only in 2 directions. The other thing we need is we need to be able to change the direction we're going and also probably show the user what way they are actually going. So let's get out of that game and add some of those. Let's start with the player line designation. So there's only 4 directions we can go, so let's just build all our directions we can go. We'll use some lines for that. Directions. So it'll create us space for 4 shapes. Yeah, it's an array. And so when we create our triangle, we should create 4 lines as long with it. Shape line. So here you can give it points. You can give it a length and a width. And then you can rotate them. Let's just go with giving it 2 points and a width. So the width is going to be 1. So let's just set that now. So we'll do it in clockwise directions, starting from up. So M direction 0 will be the up direction. So it's going to be an upward facing arrow. And so our top right corner of our entity is going to be 0, 0. So if we use our half width when we're going up and down, which is 20, half of that's 10. So going from 10 in and 0 off the Y. Let's make it a line that's 20 pixels long. Oh, it's also in 10, and it's facing upwards, so it's a minus. Goes from 0 to minus 30. It's 1 width long. Let's add a bunch of these ones just so we can see that they work, and then we'll hide the ones we don't need. Oops, 3, 2. So our second one is going to be to the right. So it's going to be, again, 10 down. It's going to be at the line that the player is on. So I think this probably should be different, but we'll just leave it at there. Actually, I don't think that works. I think this has to be 0 and this has to be minus 7.5. So that'll take it down halfway through the triangle. It's on the same Y line. And then here it's going to be 30 long. And it's to the right, so it goes from 0 to 30. And so there's thing takes ints, not floats and doubles. So we have to cast these down to ints, so we'll just leave it at 7 then. Probably look just as fine. Now the one going down, we can change this to be just going up 30, I think, yeah. And then the one going to the left. So halfway down, and then you want to go to the left by 30. But this needs to start at 10 in, goes to minus 30. I believe, and then this is going to be minus 7. Alright, so now instead of setting it to one graphic, we can set it to a graphic list. This takes any amount of graphics, so m graphic, and then our forward directions. So now we should have our thing going around, and I think I have to name their colors. They're all just going to be white. So now we have our things that get added, so they should all draw. We'll worry about hiding them in a second. Oh, while that's loading, let's start working on the waiting game. There we go. So there's our lines. They're kind of messed up, but we have lines. So you can see they use that as the origin point, which is not quite what we wanted. But we have lines. So our thing draws as if it's in the center of the origin. So that means our X is the center origin. So we don't need to do all this plus stuff to it, I guess. Oops, my bad. They can all originate from the center of the thing. Alright, so that goes from 0, 0 to, so when going downwards, 0 and 30, minus 30 for going up, 30 for going to the right, and 30 for going to the left. So I'll pause it. Well, here we are. Looks a lot better, doesn't it? So now we just have to hide the ones that aren't going to be used. So let's go and do that. So let's just start. We'll make a function that just hides them all. So there it goes and hides all the lines. So when you come in your update, you hide all the lines. And then we'll set one visible based on whatever we get here. So if we're going down, directions 2 is visible. If we're going up, then 0 is visible. If we're going to the right, then 1 is visible. And if we're going to the left, then 3 is visible. Which is not always true. We need to show which 2 directions you will go. So we will actually not do things there. So we'll say if we're going down, if you are capable of going down, you will show that. Otherwise, you will show the other one. You will show up. And then if right, you show that you're capable of going right. Otherwise, you show that you're capable of going left. And so we can get rid of all this now. And we'll run that. I'll pause it while that loads. So as you can see, we have our 2 directions. I actually showed all 4 directions at the start, so we should probably clean that up by making them all not visible at the start. So it never has a chance to show them before the update function. So you just do that with hide lines here. Alright, so that's that. Now we have blocks that we can hit. We have our thing showing which 2 directions it can go in. If you touch the screen, it goes to the other direction. There's the things that will actually change your other direction. So let's create a switch block. We'll need, they'll be similar to block, but we'll change them up. So actually we're just going to inherit from block here. So that means that we need a width and a height. So these switch blocks are going to operate pretty much the same as the other blocks, but instead of crashing into and restarting the game, they're going to not do that. So we will create a type for him, which is a switch block. And make sure to set the type of that. So it's going to go through and call the blocks thing, which will set the type of it to be a type of block, and set a graphic for it. But that's not quite what we want, so we reset the type. I'm also going to get the color of it, or change the color of it, so we can see different things based on that. Now there's going to be two different types of switch blocks, the type up and type down. So let's have that be a value of these things. You only need two because they can only switch one direction wise. So is it type up or down or left or right? So having that be false, we'll say that means it's a left or right one. Let's add it to the constructor here then. And we set that up. Set that variable up. Let's create a getter for it. A little bit verbose, but whatever. And up down. So now that we have this block, it's a super block. It's a switch block. We can actually add them to our engine now, and when we collide with them, we can alterate which direction we're going. Now, the way these things usually work is that when you hit them, you start going the opposite direction, and you can only hit them going in one direction. So if you go into it going right, then now you're going left, so you reflect immediately back on it. So you can't actually go through it more than one time. I'm sure there's going to be some little edge cases that will hit, but let's add one to our world. And let's put it just in front of us so we don't have to do a lot of work to hit it. And we'll make it an up-down one. No, it has to be left-right, so that we can hit it. Let's put it just right next to us. 550. So when you hit it, you should change and go to the left direction, is what we're saying. So let's go to our player. If we collide with a world, if we collide with a switch box going in the direction that we were going to go, and now here I'm actually going to do a, because we need to know if it's an up or down thing, I pull out the entity that we hit. So E should be a instance of a switch block, because that's the only type that we have there. So we can cast it to it. And now we can say so even this is probably unnecessary, because you can just tell based on what direction you're going in if you're hitting one that should reflect you, because you can only go in polar cardinal directions. But we went with this, so let's just continue with it. So if you are an up and down one, you set down to equal not and down. Just invert it, and similar with M right. Really, you could do this if you hit any of them. But what we should do there is set MX to be your current value. So it was the step before you hit that block. And then that'll set it back in, and we'll just run it and see what happens. Oh, I didn't actually change the color of them. Um, so we know it's a shape, so it's going to be a little difficult with me, but let's just see. If you are up and down in Swift Stitch, you are blue, I think, and if it's in the other direction, it's red. Yeah, so let's just go with that. It's a nice faded blue. It's a bluish. I need to import shape here from my AndroidPunk stuff. So if you're not up and down, it means you're left and right, and so we'll just use a reddish with that. So by that we should need to change that to be public. Alright, so now we need to, what was that, 2 different types of switch blocks here, just so we can see the difference. Let's put this one above the other one. No, that doesn't make sense. Silly. Put it above one of the other blocks. So at the 750, they're all 30 by. Put it underneath the other one. Let's change these around just to see what happens. I'll go ahead and pause it while that loads. So there's our blue box. The red kind of confuses that. Here's some interesting bugs right here. So blue is supposed to be up and down, but we hit it going to the right. So that's a mistake. That's not supposed to be possible. Oops. Usually you design the levels so that they're actually, you're driving through lines, and so you can't actually come up from a different angle on a line, because it's a line. So in order to fix that, while I'm at it, I'm just going to switch this up to be a little different, a little more faded gray red. And now I have to move it out of the way a little bit, just so I can't hit it going to the left and right, which means I should change this. And I'll put this one above the other one. Let's take a look at that. So that means I have one where I'll come and I'll hit the X, and then I have a one above that one that if I hit it, I'll switch down to go to the Y. So it should sort of trap me in there. So there, we hit one, changes, it should change our X. And yeah, my Y is not changed, but my X is. So I'll just crash into this so we don't. So I need to put that below that X in order to see it reflect properly. Loads that up. There, that's what we wanted. Hopefully I don't hit it. There we go. Reflections in both directions. So that's the basics of it. You have things you can crash into that restart your world. You have these blocks that you can hit. Now you just have to design the levels such that you can't hit these blocks in out of order. And yeah, that's sort of the game. All you have to do is crank up the speed, and the difficulty gets quite increased. Creating the level like this is quite difficult. If I continue this tutorial, I'll show you a little bit of OgmoEditor. I'll just open it up and give a little quick show of it. Let's create a new project in our folder. Swift something, there you go. Now a good place for this is usually just create a folder, and I'll just create it in the assets. Create a thing called levels, and then I'll call it Swift Switch. So OgmoEditor is a little level editor. Everything's degrees. Made by Matt Thorson. I'm pretty sure I'll put a link in the description of here. You describe how big levels are. Our levels are 800 by 480 at the minimum, and then we can just make a maximum of whatever we want. Double the size. Create a camera, it shows you a nice perspective. We don't want to export it. Level values, these are things that'll get attached to the exported level. Right now I don't know what we need, so I'll just create that. Now we need to add some things. There's layers, so let's call this the objects, and the grid is going to be, I'll just make it 32 by 32. And we'll call it entities. To do that, you need to create something, so we'll have a block. Their size 32. And they're not resizable, we'll just place more than one. The better way to do this would be to create a grid, but we'll go over that in a later time. So blocks are going to be dark red, makes sense. They're 32 by 32, and now we have an object layer, and then we'll create a new one called the switch block, and they have the is up down as a boolean, and their default is false, and then these are going to be, let's go blue. The other way we could do it is create two different types of blocks, which is probably the better way to go. So yeah, let's do that. So create an up-down block, 32 by 32. We should probably change the up-down but we'll just leave it as a huge block. And it's as a boolean. That doesn't matter. It's an up-down block. That we can set that in code later. But we can set its color to be different, so we'll do that blue color, and then we have to create a left-right block, and these are going to be that like pinkish color, just cause. Make it a little more purple. So now we have a layer of objects. We don't have a tile set, we don't need that. Apply it. So now you can go in and place some entities, things you can't hit. Now this is completely not a really great way to go, because each entity is going to have to be created as an object, and you're going to be creating huge things of levels. I guess we also need a goal or something you need to get to, so let's just add that entity. Yeah, there's a thing where you can't, you have to close the project but when you add that, but we'll have a goal. It's 32 by 32. And let's say it's resizable in both directions. I'll go over what that means later. And goal will be this orange color. You can attach images to it if you want. Since this is a pretty quick tutorial, we'll just do it like that. So we have a goal, a bunch of blocks around it. One thing I also forgot is a player, but whatever. So oh, these are also the incorrect size. So let's just save this level and so we can open it up again. Now we can add the project. So this is 32 by 32. We'll change that probably later. The goal, we also need a player start or a player. There's a limit of 1. This is going to be where you spawn. Let's just call it 20 by 20. And the origin is 12 by 12. I think that inserts it into the center of a square. Let's take a look. Not quite what I was looking for. It must be minus 12. Too much, minus 6. And so there we have a player, we can put it in the center of the block. So we'll start off going right and down. Let's do the most basic splits level you can get in this game is to have to go hit an up down block at the bottom here and then hit the left right block over here and to reach the goal over there. So you'd have to come over, you'd hit this, it would take you back, or if you go down any you can get it out. So let's actually erase this here. So you actually have to go down here or else you will just reflect back and crash there. So that's a level. Let's save that level. I guess I'm going through the Agua Editor tutorial anyways. So that's our level. Let's open it up, see what we got here. Put it in assets. Here, so we got a block, a whole bunch of blocks. A couple up-down blocks, a left-right block. It's just XML and some goal squares. So what does that mean? We need to create a goal square. Goal entity. So we can test when we actually collide with it. They've always been 32 pixels, so let's just how to force it to be that. It's pretty not the greatest way to do it, but they're not given a width and height, so you have to assume the 32. So create our rect. 32, 32. And we want to set our type. Goal. So there we have our, we'll know if it hits anything of the type goal. It'll look like a rectangle. We need to set the graphic color. What is it? Just use what we use here. It's FF80. So there's our color, our graphic, and we can place them throughout the map. So we have those, we have our blocks, we have our switch blocks. So we have all our entities implemented that we used in the that we used here. We have our player class, we have our switch blocks, which we doubled up on. We have our block, our player goal. So let's create a game. loader. So it's in the assets directory, which we can open up at runtime to load up. So Swift World, normally you'd give it like a level thing, but we'll just hard code it. Let's just store this away for now, and we'll create a world based on it. And this is going to load from a file, which would be an input stream in JavaScript. I'm at Java. So here we can use get asset. So let's just hard code it to level 1. Levels level 01.oel. So this is not exactly what we needed here, but let's get rid of this because that's going to return an input stream. Did it wrong again. Alright. Load input stream files. And when this thing gets added to the scene, we load this asset. There we go. So now we have our input stream. We can load it into a document. No, I always just look back at my code sample for this because there's no need for me to oh, you can just call getXML and it'll do all that for you. Cool. I knew I implemented that before, but yeah. Oh, wrong thing. So let's go back to our Swift World. So instead of that load, we'll just say getXML. p.dot. So you give it the asset file, which is going to be our level. So now we're saying you give it an XML DOM object, and now you can actually take your level and grab out all your entities and things. There's a decent way to go through this is you build handlers for the types of objects you need. I have that partially implemented here. You can pull out attributes of the level if you have any, like the width and height, which I will as well. So again, I'm just going to copy from something I've seen. You feel free to copy from my thing if you want. I'll change this to doc to be consistent. And now we have another. So now that'll parse out the width and height of the level object here. So we'll get 800 by 480. So now we have to parse through the objects. Now this is where I'll just go over here and take a look at something. Yeah, get element by tag name. And so you get your object list. If you have any objects to display, now you can iterate through all your objects. Like so. Yeah, so the way the DOM works is the standard W3C DOM. So your get elements by tag of objects. There's only one object in our level. So it's going to return a node list of those objects. And so you take your node list. If is one, then we pull out all our objects by grabbing that particular element as child nodes. So now we have a node list of all the things that were inside of this. So we have our now player, block, etc. And so now you can iterate through all the nodes of object type. So now, well, just for time, we're going to do a huge if-else tree. I'm just going to snag it from there. So if it's player, then a nice Java thing to do is you do the constant dot equals, so that if this is null, then it doesn't crash your program. So we have to get our XY point out. What else is there anything else to take other than ID, which we're not going to use, the X and Y. So we take the X and Y, parse them out, new players at, print out where we're at, create our new player, and add to the world. And chain this, make this huge if-else chain where if you're looking for block, now block has similar attributes, it's just X and Y, and then we have to create one of them. So you see there's a lot of repetition here. Just add a tag quickly. In OgmoEditor, my previous world that I've been working with, I create these handlers in a hash table. I'll quickly show that just so you know what I mean. And so I look, if it contains that type of key, it'll add something it creates. And so what you end up with is this map of constructors that are these little, they have these functions for make, and if you pass in the particular node, it'll use that node to generate a particular object and return it. So these XML entity constructors return an entity given a document object. And then it really simplifies your if-else thing down to, if this exists in the hash table, then run its make command. As you can see, it can get out of control if you have a lot of different object and entity types. So just a word of warning, don't do what I do. Alright, so now the next thing is a block, so we need to add block. Add XY 32 by 32. That's just what we've defined. I could have added width to the thing. In fact, that's probably what I should do. And that's probably what I'm going to do right now. Block. Because it just makes sense to have these be resizable. And then you have one that you can resize generically. So we apply that, we'll open up our level. So they default to 32 by 32, but you can use this resize here to go like so. And so then that's one entity of a larger than 32 by 32 size. If you went for some sort of tiled approach, it probably wouldn't look so great. But now we can actually replace a lot of this with a couple entities that are just stretched. Now these keyboard shortcuts are pretty nice. This is 1, 2, 3, 4, 5. So I'll just go through and resize these to lower the number of entities we have to have. I'm going to actually draw this from the top down, just so the X position is going to be the top point. I don't know if it always is. If you, let's just try this out now. So it's 64. You can't resize it up, that's why. Alright, makes sense. And then this. So now we have a lot less entities, and the same information is sort of there. Yes, replace. So now we only have a couple blocks, and they all have width and height attached to them. So now we go back to our world and we pull out the width and height. We do that the same way. Probably going to end up doing the same thing with the other type of entity blocks. Let's just do that now. This left, right, one blocks is ridiculous. So let's just do it right now. Oh, we need to set them to be resizable. In both directions. Apply that. Load the level. Delete. And draw. Resize. Save. Refresh. There. Now we only have an up-down block and a left-right block, and then a couple blocks with greater widths. And everything has a width and height, so it's even the up-down block, which we didn't specifically say, has 3232, so it'll have the default actually in there. Alright, so now we have our width height, we parsed it out, pass that to the block here. Now what I'm hoping is in my switch block, we didn't actually explicitly say 3232 anywhere, or in block. It was all by width height. Alright, so we're good. The goal will be 3232, which we should change because that's not what we want. We want width height as well. And we'll change it in our project as well, so that the goals can be resizable. Oh, they were. So let's delete these two, add a goal, resize it, save it, take a look. Now we only have one goal, and it's a height 64. So now we go back to our Swift world. We have a width height. Now the blocks are pretty much the same as this, so let's just add in a couple one. Let's do the goal. We add a new goal. Goal. Just log out some stuff so we can see that things are happening the way we want them to. This is going to be an up-down block. Just make sure that's what we called it. Up-down block and left-right block. Gotcha. So an up-down block is similar to a left-right block, just that the Boolean is changed. So it's still a switch block, but it's up-down. It has this set to true. So we can do basically the same thing for the left-right block. And then set this to false. So that's all our level parts. We have the player, the blocks, the goals, the up-down blocks, and left-right blocks. So our 5 things. So what do you want to bet that it works when I run it for the first time? Everything looks like it should work to me, but I've been wrong before. So let's run that. Yeah, hope you guys have been enjoying this. I've never done something like this before. Hour and a half, and I have a game with some sort of levels, a basic clone of another thing. Let's see if it works. Holy moly, look at this. It loaded first time. I hit that. I have to go down. Oh, I hit that. So I have to go down and hit that blue one first before I can hit the other ones. So this will bonk me up. Oh, my goal's not rendering properly. I'll have to fix that. But here's a basic clone of a game. So I let go, bounces me there, I can move up a little bit, and I'll hit that goal. Now I don't have anything that says finish when you hit the goal, but let's just do that right now. First things first though, the goal needs to done right. Don't know why it's not. Goal has a height of 64. Ah, that's why I didn't have the hitbox or the graphic. So that fixes that. Now we want our player to finish when you hit the thing. So if collide so if you collide with the goal, then let's print something to screen and pause everything. I don't know. Best I can think of. Get the world, add a just going to put a uwin entity or a uwin thing on the screen. This comes with a default font. You use it by the atlas text. You can just say uwin, and let's make it pretty big. Set its graphic to the atlas text. Add the text entry to the world and remove the player from the screen. Let's keep it simple. Now, how do I guess I remove this from it. So it'll add the text to the screen, which I need to position properly at height, half width. I really should change these to ints because it really doesn't make any sense. Or have int versions of them, because I'm going to have to cast them to ints here. Now the text draws from the top left corner. We don't want that. So we can actually offset the atlas text by setting its x to be half of its width. Equals minus at.getWidth. And we'll get its height and do that as well, so it'll center properly. Yeah. So get width, get height. So this now should draw in the center of the screen and then remove the player from the thing if you collide with the goal. Seems good to me. There'll be no restarting or anything like that. Hopefully this works. So, oh, whoops, you started in the goal. That is because the player start is not centered right. So let's fix that. But there you see the you win, so that's exactly what we wanted. That's cool. But the player didn't have to work for that, and that's not cool. So let's add a little bit to our player to add that offset. It was 6 pixels by 6 pixels. So now the player shouldn't be able to win right off the bat. And hopefully that'll be what we want. Derp. Okay, that's not exactly good. Oh, -6 because of silly me. So the y grows downwards. So this is 0.00, this is 0.0480. So by adding 6, I moved it up it still shouldn't have been in the goal because I added, yeah, so something's definitely wrong here. Now I'm not going to remove my player from the game. I'm just going to pause him or something. No. This is why debugging sucks. Here we see, let's take a look at the level. Players, the first thing should be at 360 and 192. So if we look here, player is not being set properly. So that's something, but that's because, haha, up down block. So it's probably the first one, 352 and 192, and then the goal block is 320, 128, but has a height width of 640 or 64. So that means it stretches down to 172. Our player spawns at 288. So be well outside of the range. Wait, 512? Oh, right, wrong block. That was the up-down block. 192. So that's well outside of the range of the Y. Did I set the hitbox width height correct? Correct. Swift world, goal. Width height. All looks right to me. Width height, goal at. So some reason it's saying it's colliding with the goal right when it starts. I'm adding 8 or 6 to this value in order to move it 6 in. So if you look at the bottom, the nice thing there is you can see that this is 320, 120, 352, 192. So that is what my player is getting out of it, and the goal is at 320, 128. Which, because, yeah, 320, 128. So why are those two saying they collide? Now, I think I messed up. I have to say if this is... No, that's correct. If the player collides with the goal at its position, because it's not equal to null. I'm sorry, I'm kind of walking through this. I might cut this part, who knows. Probably not, though. Learning experiences for everyone. Just going to not remove it for now, just so we can see what is actually happening. Now, there's many things that it could be, but we'll have to wait and see. Oh, so now it works. Alright. It seemed a little bit too high off the top there, so I'll work into that. My -6 when I was supposed to +6. There you go, so I didn't remove it, yeah. Oh, it looked like it was inside of there too. So yeah, this is supposed to be +6. And so with the player, I think I keep dying. I keep bouncing back and forth because I have +6 to it, so I keep hitting the win marker. It's not what I want. Run a new version of it. So that'll put us in set, so it shouldn't collide. Still looks like it's inside there. So the width is 20. I move it down 6. There should be another 6 space on the bottom of it. Interesting. one of those things where you'll see it when it's done, but you won't see it unless you look. So X is at 352. The goal is at 320. So those are off by the 32 blocks. A player going to the right. Oh, that's right. Its hitbox should be for it going to the right off the start. Not that that changes anything. That's right, it draws from its XY location. So I need to add 16 to it to get it to the center of a block. Right, this is why you always use the top left corner and not the center. You fall in these little issues. So let's run that. Coming up on an hour and 40 minutes here, so there looks a lot better. So this should bounce right back and crash. And then I will probably call that the end of this video. Look at that. So now let's do it correctly. You tap to go down, you go up, you bounce off that wall, and then you're in your goal. So it says you win, and then you crash. Alright, so now I can remove myself from the game. And now I'll call that the game I have set up. Now you can go and create levels and use OgmoEditor, and it's really awesome. And that's that. Cool. Hope this is interesting to people. There's lots more available in AndroidPunk, a whole bunch of sprite maps and stuff like that. Could show you a little bit of that, but yeah, why not? I'll show you the intro video of the other game I'm working on, because it'll show you what it's capable of a little bit better than some squares, rectangles, and a triangle. So while that installs, this is probably not going to run as smooth as a couple of squares will, but I guarantee this runs very, very well on the actual devices themselves. There's a whole bunch of extra features that I don't list here, which is if you enable debug mode, there's a whole bunch of like tutorials and commands that you can add. So this is Jumper Mobile's game I'm working on. It has a little bit of story to it. There's your little guy, Ogmo, from the Jumper games by Matt Thorson, who also made OgmoEditor. And then he flies into the warp zone, which is pretty much Super Meat Boy, I guess. And then you have your game where you can move this way. Bonk, bonk. And you get a little bit of sound. To jump, you'd have to tap above. No. So that's you can just tap with a second finger and it'll jump. I added if you touch above the middle here, it'll jump straight up. And so this is just some stuff you can do with AndroidPunk. We got a little animated sprite there. You got sounds, you got everything you want. So cool, hope you enjoyed this video. It's got all menus and stuff. You can disable the sound. This is all open source as well. You can check out the GitHub page, and this project's all on GitHub. Thanks for watching. See you maybe next time when we add some sharper graphics, some sound, maybe more levels, things of that nature.